Let's begin. Acceleration. The physics definition is, and I'm quoting, the rate of velocity change per second. Say what? Acceleration is how fast your velocity is changing. The more you're accelerating, the faster your velocity is changing. In this section, in fact, in this course, we're going to look at a constant acceleration. I'm going to go to a car example. In this course, we'll be able to step on the gas or we'll be able to hit the brakes. But once we've done that, we won't be able to handle stepping on the gas harder or hitting the brakes harder or pressing on the brakes gently and then increasing. That we need calculus to deal with. A changing acceleration, you really need calculus to deal with. So we'll be doing what we call constant or uniform acceleration, and that word will show up in some notes later on. The units for acceleration are meters per second squared, or meters per second per second. I think I already yelled at you once earlier about it's worth memorizing units. And so you want to file this away, but I think you will. If I see a number and next to it there's meters per second squared, I know right away, oh, that's the acceleration. The same way as if I see a number and I see a meters per second next to it, I know it's a velocity, maybe the initial velocity, maybe the final velocity. I'll read the question and figure it out. Acceleration is a vector. It makes a difference which direction you accelerate. If you're going forward and you accelerate forward, you'll speed up. If you're going forwards in a car and you accelerate backwards, what will happen? Slow down. That's what hitting the brakes is. Hitting the brakes, we would say that is a negative or a backwards acceleration. We don't say decelerate. We just say you're accelerating, but in the negative direction, and that'll cause you to slow down. Oh, unless you're in reverse. If you're in reverse and you accelerate backwards, you'll speed up. If you're in reverse and you accelerate forwards, you'll slow down. It's a bit tricky to visualize its direction, and so we're going to practice this. The difficulty in visualizing acceleration is we tend to confuse it with velocity. The direction that an object is moving and the rate at which it's moving are both related to the velocity, not the acceleration. You can be moving forward and accelerating backward. You'll be slowing down. You can be moving backward and accelerating forward. You'll also be slowing down. You can be moving forward and accelerating forward. You'll be speeding up. But the direction part comes from the velocity, not from the acceleration. So to determine the direction of the acceleration, we need to watch the object for a period of time. And we need to observe how its velocity is changing. We're going to do some examples here, Braden, intuitively longhand. And then we're going to ask, please God, is there a shorter way to do this? And there is. So I've got a chart. We're going to look at 3 specific examples. We're going to have an acceleration of 1.25 meters per second squared east. Instead of writing east, I'm just going to call it positive. Am I positive? Yes. And then we're going to look at 3 different initial velocity situations and observe or figure out or derive what happens second by second by second. So let's suppose that our initial velocity in situation A, VI for V initial. What does initial stand for? What does I stand for? Initial. What does F stand for? Final. Is 0. So in situation A, and I'm going to zoom in a little bit so that Braden can see at the back. I can fit that in. At time 0, we're going 0 meters per second. We can fill that in. This is when we start our stopwatch. 1 second later, if this, let's pretend this is a little toy car. If this toy car is accelerating at positive 1.25 meters per second every second, how fast do you think it's going after 1 second if we start at 0 and it's increasing its speed by 1.25 meters per second per second? That's the question. And this one is maybe so obvious that it's a bit tricky. I'm going to argue that, after 1 second, it's going that fast. Because that's what its speed is changing by every second. It's still increasing its speed by 1.25 meters per second per second. Instead of saying meters per second, I'm going to say meters per second squared. So how fast do you think it's going after 2 seconds? I think you're right. Loud? 2.5. Yep. Okay, Sarah, Smarty Pants, how fast do you think it's going after 3 seconds then? Can you do the math in your head? Or use a calculator, I don't care. 3 point, yeah. Here's the question, Sarah. After 1,000 seconds, how fast is it going? Do I need to calculate the previous 999 seconds? Or please, God, let there be a way I can get there in one step? That's what we're going to ask ourselves later on. Okay? So that is starting at rest, VI was 0, and accelerating forwards, and your velocity and your acceleration are in the same direction. What if we were already moving? So situation B, VI is 2 meters per second. How fast are we traveling now after 1 second? Yeah. Are we? 4? What's our acceleration as a number? 1 point.
Oh, 1 point. Oh, never mind.
So you want to revise your answer? Go ahead. Yes. And then after 2 seconds, it would be going another 1.25 faster, which 4.5, I think, yes? And after 3 seconds, it would be going... And again, I would ask the question, okay, 1,000 seconds from now, how fast is it going? Is there a way that I can get there in one step? Yes, there is. Ooh, in the third situation, how fast was our initial velocity? I've scrolled down. What did I say for part C? I think it was negative something. Negative. Okay. Now it's going to get a little trickier. By the way, when I say negative, what direction do you think we're talking about? Let's go backward. I mean, west, I think, on the compass, but I'm thinking backwards. Okay? Typically, if I'm trying to visualize this, plus will be forwards or up. Negative will be backwards or down, depending on which type of a situation I'm looking at. Is that okay, Ethan? So I'm in reverse at 2 meters per second. That's when we started our stopwatch. But I'm accelerating forwards. My speed is changing by positive 1.25 meters per second, meters per second squared. So how fast am I going after 1 second? I'll give you one hint, not -2. Yeah, Donald. Yes. What's that negative telling me? I'm still going in which direction? Or backwards. Yeah. West. Good point. Even a better answer than backwards. Okay. I'm accelerating forwards at positive 1.25 meters per second squared. How fast am I going after 2 seconds? I heard someone? How'd you get that? Yeah. So if I go negative 0.75 plus 1.25, I don't think I get one. Do I get 1.5? 0.5. I think 0.5. Is that okay? By the way, after 2 seconds, what direction am I traveling now? I can also tell you somewhere between 1 second and 2 seconds, I must have very briefly come to a stop and changed direction. It has to have happened between there somewhere. So there's some good information I can glean from this. Okay, after 3 seconds, now I'm back to the original 2 examples where I'm going forwards and accelerating forwards. So after 3 seconds, here is at 1.75, yes? And I would again ask the question, what if I want to know how fast I'm going after 1,000 seconds? Please tell me I don't have to calculate the previous 999, and I don't. We're going to come up with an equation for acceleration. So I wrote here, there has to be a better way to do this. There is. Next page over. Whenever the velocity of an object changes, the object experiences acceleration. Now, I should point out, velocity is a vector. If I was a good teacher, I'd have a dumb way for you to remember that, but you're on your own. All vectors have magnitude and direction. So there's two ways that you can accelerate. You can change your magnitude, speed up or slow down, or you can change your direction. If you're going around a corner, your speedometer isn't changing, but your direction is changing, you are accelerating. That situation where you're accelerating because of a changing direction, we'll look at mostly in Physics 12. But I got to point that out now, that there are two ways to change your velocity, two ways to accelerate. Speed up, slow down, or turn. Okay, anyways. Acceleration is defined as follows. I said it was the rate of change of velocity over time. It's the change in velocity divided by the change in time. What's our symbol for change in? On your green sheet, but you might have committed it to memory already. I don't know. What's our symbol for change in, Donald? Can you say it like a nerd? Starts with the letter D, also a city kind of near Surrey. Okay, delta V over delta T. Oh, but Donald, what's change in anything also on your green sheet? So that delta V I can write as V final minus V initial. And technically, I could write that delta T as T final minus T initial, but for some reason, Braden, we're lazy in physics because time is always a change in. We just don't bother putting because the only way you can measure time is to start and stop a stopwatch, and that's automatically doing the final minus initial, and so it's kind of redundant, and we say whatever. Okay? So we're going to come back to the symbol. Well, the symbol, lowercase a with a vector sign. Units. Well, who remembers what were our units for speed or velocity last lesson? Well, we said velocity was distance over time. Don't write that down. What are the units for distance? What do I measure distance in? Starts with letter M. What do I measure time in? So the units for velocity are meters per second, and then that time on the bottom. This is why earlier I was saying acceleration is meters per second, but there's really two S's on the bottom. There's a better way to write meters per second. A better way to write meters per second is meters per second squared. And I mentioned that already on the previous page. Who remembers acceleration, scalar or vector? Vector. Okay. Velocity has the same symbol as speed, which is V. V with a vector is velocity. V without the vector is speed. If the velocity at the beginning of an interval is VI for initial, and at the end is VF, change in is final minus initial, like we just said, blah, 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 blah. You know what? In the box here, here's our equation for acceleration. A equals VF minus VI over T. I don't think I actually gave you that one. And there's a reason I didn't give you that equation on your formula sheet. I did, but I disguised it. I wrote it without fractions. By the way, how many variables are there in this particular equation? How many variables are there in this particular equation? If you're not sure, you might want to look up. I'm giving you all a big hint. How many variables are there in this particular equation, Naomi? 4, very good. That actually means this is 4 different equations hidden in there. You can memorize all 4 different equations because I'm going to show them to you later. Or better yet, you can learn to derive them with me in your head and not have to memorize them. This is that weird formula manipulation that I was alluding to earlier. Oh, Donald, note, change in anything is always, what did you say? I realized this was 3 whole minutes ago. It's on your green sheet. What's changing anything? Oh, yeah. Okay. Don't let me down, Donald. I got to get, there we go. Good. By the way, if you haven't figured it out, the fact that I've said that little line about 8 times so far this year probably means it's going to become important eventually. Hint, hint. Especially next year, and next year I don't give that to you on your green sheet by Physics 12. I kind of expect you to have it here. Since velocity has 2 aspects to it, speed and direction, acceleration can occur if speed changes, like I said, if the direction changes, like I said, or if both speed and direction change, then you're clearly accelerating. This unit, this year, we're almost exclusively going to be looking at situation A, where your speed is changing, but not your direction. Example 2. A runner is racing in a 100-meter dash, and they accelerate from rest to a speed of 9 meters per second in 4.5 seconds. What's his average acceleration during this time interval? Okay. Here is our first official physics word problem, sort of. I'm going to use an approach where I list everything, and we're going to formalize this a couple of lessons from now, but this is that DFIC thing that I kind of snuck in last day, where I said I list my data, I find a formula, I insert the numbers, and I crunch an answer. But the first question I always ask is, what is this question asking me to find? What is this question asking me to find? I'm going to write down A equals question mark. Why did I say average acceleration, Sarah? I've watched runners. I don't think they're accelerating at a constant rate, but we can't deal with that without calculus. So this year you'll often see me, because I'm a nerd and I'm nitpicky, you'll often see me put the word average in front of acceleration. That's my way of telling all of you, yeah, look, I get it. Probably the acceleration is not the same all the way through this particular situation, but it's still a neat situation to look at, so shut up. In a nice, loving teacher kind of a way, okay? So A equals question mark. Oh, I'll even put the little vector symbol above it. That 100 meters is a distance, and right now we're not going to use it. Don't cross it out yourselves, but that right now we're not going to use. What I'd like you all to do is underline 2 physics words, the phrase from rest. That's a word from now on, ding, 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 that you want to spot. In fact, you may want to get in the habit of just always underlining it. I always mentally underline it. When I see it, it's already highlighted and underlined. That tells me something. That tells me VI. What was the initial velocity exactly as a number if we start from rest? 0. So let's write down VI equals 0. Oh, what if instead of saying from rest, what if it said came to a stop? That's telling me that VF is exactly what? Okay, so those are 2 physics phrases you want to keep an eye out for. You want to look for numbers and physics phrases. The other number I see is the 9. What are the units right next to the 9? What do I measure in meters per second? Time? No. Oh, it's a velocity. Which one? Well, since I already wrote down VI, anybody for VF? V final? Then, Rachel, I see a 4.5. What are the units right next to the 4.5? So it's a time, you say. Now, by the end of this course, you will have a lot of physics knowledge. So when I say to you, I'm looking for an equation that has an A, a VI, a VF, and a T in it, right now, Mason, you're going to roll your eyes. You're going to say, Dewick, we only got one equation. I know, but in a few days, you'll have more to be choosing from. So right now, we only have one equation. It's the one in the box. It says this: A equals VF minus VI over T. What's VF? Yeah. 9. Yeah. What's VI? 0 divided by T, 4.5. I can actually do this one in my head, Naomi. 9 divided by 4.5. I made up some nice numbers. The answer is exactly 2, yes? I like to give my answers to 2 or 3 sig figs, so I'm going to go 2.0 just to make it look prettier. It's an acceleration. What are the units for acceleration? I heard somebody say meters per second squared. I often have a habit of drawing a box around my final answer. That's like spiking the football after a touchdown or raising your hands in the air when you win the gold medal. And also it's because in Physics 12, we'll be doing questions that are an entire page and a half of work. And when you find that answer, you want to make sure that you know where it is, or you know you're going to be using that to find something else and you don't have to go hunting for it. So habit that I've developed, I won't take marks off. You don't have to, but I'll often put a box around my answer. Turn the page. I think it's turn the page, yes? The standard unit for expressing acceleration is meters per second squared. So if an object is accelerating at 1 meter per second squared, its speed is increasing in the positive direction by 1 meter per second every second. If they're accelerating at 10 meters per second squared, every second their speed is increasing in the positive direction by 10. If they're accelerating at 500 meters per second squared, every second they're 500 meters per second squared, by the way, is a pretty big acceleration. You'll learn later on that 10 meters per second squared is right around 1g. We'll talk about that later on, Monday or Wednesday. A UFO is reported as accelerating from rest. You know what? To 680 kilometers per hour in a time of 2 seconds. What's its acceleration? Put your pencils down, look up. What's yucky about this question? Yeah. Units. Units. Okay? There is a slightly accepted version of acceleration that measures kilometers per hour per second. So at the bottom here, I wrote blah, 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 blah. I gave you the answer as a matter of fact. If we did this with kilometers per hour and seconds, we would get 340 kilometers per hour per second. I hate kilometers per hour per second. I tolerate it because of cars. I think, you know what? Oh yeah, I wrote that there. Tolerates it because of cars. Here's what I'm going to say. Let's convert it. So first of all, what's this question asking me to find? A equals question mark. From rest. What's that telling me? Oh, VI is 0? What's that 680? Well, kilometers per hour, that's definitely a speed or a velocity. By the way, right now we're just finding magnitudes. I didn't make up directions for a lot of these. You know what? If you get a positive answer, let's assume forward. If you get a negative answer, let's assume everybody backward. Okay? Did somebody say if you get a negative answer, let's assume negative? Well, yeah. Okay. So I think that 680 is V final. But Garrett, what didn't you like? It'd be cool if there was a way I could convert that to meters per second. Isn't there something to do with a 3.6? I can't remember. Oh, it's on your green sheet. Is it times by 3.6 or divide? I can never remember. Divide by 3.6? So I'll make a little note here like this. Do you get 188.8 repeating? I'm going to leave that on my calculator. I'm going to write in my notes here 188.8 repeating, and I'll put meters per second because now it's good units. Then I see that 2.0. What's that? How do you know? Seconds. Even if they hadn't said the word time, I could figure it out. Seconds. So T equals 2. You can put the 0.0 if you want to. Doesn't make a difference on my calculator. I'm looking for an equation that has an A, a VF, a VI, and a T in it. There is one. You only got one right now. It's going to be A equals VF minus VI over T. I'm going to write 188.8 repeating. What button am I going to use on my calculator right there? My answer button. Minus 0 all over 2. By the way, does the minus 0 make a difference? No, but if you type it in, is this a fraction? Yeah. Is there more than one thing on the top? Yeah. If you're going to type the minus 0, make sure you put the top in brackets or use the fancy schmancy fraction button on your calculator. In other words, I'm going to go bracket, answer button minus 0, close bracket, divided by 2. If I don't do that, my calculator will divide the 0 by 2, but not the 188.8 repeating by 2. And I get 94.4 meters per second squared. If I had left it in kilometers per hour, there's where you get the 340 that I mentioned in that little paragraph down below. But 94.4 meters per second squared. Is that big, Mr. Dewick? About 9.5 Gs. Not fatal. But owie. So, kilometers per hour per second is not the official accepted unit for acceleration. It's often used when describing the acceleration of an automobile because if you're in a car, you're timing in seconds, but your speedometer is in kilometers per hour. And so you may come across that sometimes in auto literature. I don't like it. I tolerate it because of cars, but I'm going to decide this year, let's do everything in proper physics units. Other ways to write this acceleration equation, you can get the VF by itself. So the original equation is this, A equals VF minus VI over T. Look up, please, for a second. Technically, there are brackets there. We don't need to handwrite them, but we do need to type them on our calculator. So I'm going to put the brackets there, and I'm going to tell you the rule for formula manipulation is simple. It's almost always reverse bedmass. Remember bedmass? Brackets, exponents, division, multiplication, addition, subtraction. You do it in that order when you're solving an equation. When you're trying to rearrange an equation, you do bedmass, SAMEB, reverse bedmass. Is the VF inside the brackets? Do it last. We want to get the VF by itself. What's outside of the brackets on the bottom of the fraction? What's the T doing to the bracket? How will I move the T over? So the A would just drop down like a domino, because it's on the left-hand side. And I would multiply a T there, and that would leave me with VF minus VI, and now I could drop the bracket because there's no more fraction. I want to get the VF by itself. What's on the same side as the VF? A minus VI. How would I move a minus VI over to the other side? Add it, and if you do that, you'll get this. The AT would stay where it was. You would add a VI, and then look up for a second, please. That equals VF, but instead of writing equals VF, can I write VF equals? That's the one that I put on your formula sheet. I think it's going to be third line down, first equation. Yes, yes? This is the one that we'll use the most as our starting point. VF equals VI plus AT. Do you need to memorize it? Is it on your formula sheet? So you need to memorize it? No, you might because you get sick of looking it up. That's the only reason you should memorize something, because you get sick of looking it up. But you don't need to. VF equals VI plus AT. I would use that if I was trying to get V final. If you tell me how fast we start, how long we've driven for, and what we're accelerating it at, I can tell you now how fast we're going. In other words, Sarah, when I said earlier, is there a way I could figure out after 1,000 seconds how fast I'm going? Yes. Easy peasy. What if I wanted to get the VI by itself? The reason, by the way, that I gave you this equation on your sheet is it's easier to rewrite this one in your head than the yucky fraction one, which is why I didn't start there. How would you get the VI by itself? Well, let's write down VF equals VI plus AT. What side is the VI on? Left side or right side? Right? Means the left side is going to drop down like a domino. It's not going anywhere. What's on the same side as the VI? A plus what? AT. That's one thing. How would I move a plus AT over to the other side? That equals instead of writing that equals VI, do you mind, can I put the VI equals on this side? Because that's where we're used to seeing the thing by itself. There's yet another equation. And again, you can memorize this equation if you want to, but I gave you this one. I'll teach you how to derive them all from this one and dramatically cut down on your memorization. It's a much better way to do this, I think. What if we wanted to get the T by itself? Well, again, I would start with VF equals VI plus AT, the one that I gave you on your sheet. What side is the T on? You got a 50-50 chance of being right here. Sorry, let me rephrase that. You got a 50-50 chance of being right here. What side is the T on? Oh, very good. So the left side is going to drop down like a domino. What's right next to the T? What letter is right next to the T? When they're right next to each other, what mathematical operation is happening between the A and the T? Remember that, remember that, remember that. How would I move a multiplied A over to the other side? Remember that, remember that, remember that. What else is on the same side as the T? A VI. What's the VI doing to the T? Is it subtracting? No. Is it dividing? No. What's it doing? How would I move the VI over if it's adding? Subtract. The question is, what do I do first? Divide or subtract? Reverse bad math. I subtract the VI over. And then look up, but don't write this next little bit down. In my Sesame Street imagination, I go, okay, in my mind, the AT has just dropped down to the next line. I'm trying to get the T by itself. What did you tell me the A is doing to the T? How I'll move the A over? Divide this whole thing by A. That's an equation for time. This is going to seem weird at first, but trust me, by this time next week, my goal is you'll be doing this almost rolling your eyes at me in boredom. And if I can get all of you, it's going to click at different times for different groups of you. And some of you will take to this like a duck to water. And some of you will take to this like a pig to climbing mountains. But you'll get, I just made that up. But you will get it if you don't quit on me. And it's a much, much better way than to try and memorize all of these. Or, I'll write every single equation down. I'll just add them all to my green sheet. Trust me, by the end of the course, it'll look like your pen puked on your green sheet because you won't be able to see anything. Okay? So, 4 equations in one. There's one for time. There's one for VI. This is going to be our starting point typically. And, oh yeah, here was one for acceleration. All of us have a built-in accelerometer. You can feel acceleration in your gut. The only problem is the accelerometer always works completely backwards. Whichever way you feel like you're accelerating, I'm guaranteeing you're accelerating in the opposite direction. I see some skepticism. Let me convince you. Suppose you're sitting at a red light and the driver floors it. Which way do you feel like you're getting pushed? Backwards. But which way is the car clearly accelerating? Got me? Okay? So you feel like you're getting pressed, but you're accelerating forwards. Your body can detect acceleration. It just feels it backwards. Oh, when the driver hits the brakes and does a power stop, which way do you feel like you're getting thrown? But which way, if you're slowing down going forwards, are you clearly accelerating? Backwards. Well, by the way, what this means is if you're ever asked a directional concept or question about acceleration, if you can imagine sitting in the question and ask, well, which way would I feel like I'm getting pushed? The opposite direction, trust me, will be right. Okay? Oh, how many of you have been on the elevator on Playland before or a similar ride? Okay. When it shoots you up, which way does it feel like your stomach is moving? Which way do you feel like you're getting pushed? Downwards, but which way are you clearly accelerating? Up. Right? Your body can feel acceleration. It's just it takes it backwards. Oh, when it shoots you downwards, you feel like you're about to fly off the seat. You feel like you're getting pushed up. You're not. You're accelerating down. There's another ride at Playland. It's called the Music Express. It's right by the pirate ship. It's the one that goes in a circle really, really, really fast. And then the DJ says, how many of you want to go faster? And everybody goes, yeah. And you go fast. Okay, on that ride, which way do you feel like you're getting pushed when you're moving in that circle? Outwards. Yes? So which way are you clearly accelerating, boys and girls? Inwards. The opposite of outwards would be inwards. This one is a really tough one. I'll do a unit on going in a circle called on circular motion in Physics 12, but I'm telling you, if you're going around a corner, you're accelerating inwards into the corner. You are not accelerating out of the corner. Even though you feel like you're getting pushed outwards, you are not. Your body is a backwards accelerometer. I have yet to find a single example where that doesn't work. No one has been able to find for me an example of, oh, the direction that I feel like I'm moving is also the direction that I am accelerating. Example 4, I like example 4, I like example 4. Example 4 is a nice question. Oh yeah, turn the page. Really, doing homework and doing the lesson? Dude, focus on one thing at a time. A car starts from rest. I would probably underline the phrase from rest. And accelerates at 4.5 meters per second squared for 3.6 seconds. How fast is it now traveling? What's this question asking me to find? Donald, thank you. I heard someone's speed. I heard someone say how fast. Let's use physics terms. And right now we have 4 things. We have acceleration, time, VI, and VF. In fact, if you really wanted to impress me, you could have said VF, and I would have got that you meant final velocity. VF equals question mark. That must mean they told me everything else. Did they tell me VI? What's VI? Oh, that's convenient. By the way, does it have to be 0? No, I can also now, if you tell me how fast the car is going at the beginning, I can still deal with it, no problem. What's that 4.5? How do you know? Even if it hadn't said the word accelerates right there, I would just look at the meters per second squared. It's an acceleration. What's that 3.6? Garrett, I did a quick scan of the units. Are they yucky? So I got lazy and I didn't even bother writing them because I noticed as I was going, nice units. Okay, I'm looking for an equation that has a VF, a VI, an A, and a T in it. It's the one on your green sheet, 3 lines down, the first one, VF. And I'm going to say to you, don't turn the page over to try and find it. Already now, start to train your eyes to look at the right place on the green sheet. You'll actually develop a little brain circuit that will do that for you subconsciously. VF equals VI plus AT. Oh, this is kind of nice. The VF is already by itself. Yay. What's VI? Come in. Hello, you're
Sorry
coming
to
to get...
interrupt, I'm behind schedule.
That's okay.
I was just wondering if there was any student.
Normally, my next question would be, okay, I want to get the thing that I'm looking for by itself, but I'm trying to find VF and it's already by itself. Yay! So it's plug and chug. 0 plus 4.5 times 3.6. And Sarah, in fact, the nice thing about this, remember when you and I did our example, I said after 1,000 seconds, you can see I can even handle it if time is a decimal or a yucky number. Not a problem. I just go to my calculator. Although, can I do this? Nah. What'd you get? 16.2. Anybody else? Okay. 16.2 what? Meters per second. And we found the velocity, the fact that we got a positive answer. If they specifically said, give me a direction, I'd say forwards or east or something. If I got a negative answer, I'd know going backwards. Is that all right? Let's do another one. Garrett, why don't I like number 5? Now, I am going to say I like number 5, I like number 5, I like number 5. And what I mean, why would I say that? I'll probably somewhere give you 1 unit conversion question on this test, but I'm not going to do 10 because I think I just did a whole test on unit conversion and stuff like that. Yes? The only reason is because cars give speeds in kilometers per hour, and I'm always going to try and show you where we can apply this stuff, and sometimes we can apply this to cars. So, what's this question asking me to find? Time? Let's write down T equals question mark. What's that 110? I know I don't like the units, but I'll fix that. What is it? VI. Oh. VI is 110, and because it has yucky units, I'm going to go kilometers per hour. Now, how do I know it's VI and not VF? This I don't know how to teach. All I'll say to you is read the time flow of the question itself and use your sense of English grammar and figure it out. Yeah. We'll get there. I got to convert this. To go from kilometers per hour to meters per second, is it divided by 3.6? Do you get 30.5 repeating? I'll write 30.6, but you know I'm going to use my answer button if I can. And now I've got nice units. Keep reading, keep reading, keep reading. 8. What's that 8? How do I know? Even if they hadn't put the word accelerates there, it's meters per second squared, kiddo. It's got to be an acceleration. Caden, what did you say earlier about stop? Oh, V final is 0. Okay. So if you want to, in our notes, you can underline the word stop as that's a ding, 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 physicsy word. I'm looking for an equation that has a T, a VI. Don't turn the page over, Naomi. I'm serious. Don't fall back on, I want you to start to learn how to rewrite these. So are you ready? The only equation I gave you on your sheet that has all 4 of these is VF equals VI plus AT. Here's how I do these. What do I want to get by itself? In my mind, or actually, I put a little dot above the T because that's what I'm staring at. What side is the T on? Left side drops down like a domino. I don't have room to drop down, so I'm going to have to work sideways. But in my mind, that VF just went kathunk. What's right next to the T? A? How would I move that A over? Remember that, remember that, remember that. What else is on the same side as the T? How would I move the VI over? Subtract. Which one am I going to do first? Reverse BEDMAS. I'm going to minus the VI, divide the A. That equals T. And Naomi, if you resist the temptation to look up the equations, you're going to find by, I'm saying Wednesday next week, you'll be doing that in your head far faster than it would take you to try and look something up anyways. So it's going to be 0 minus I'm going to write 30.6. but I'm going to use my answer button, divided by 8, and something weird happens on your calculator. What are you getting on your calculator right now that's making you a little bit nervous? Time can't be negative. We've screwed up. And I did this on purpose so that you can look at your calculator and say, oh, I'm not going to panic. It means I missed something. For a candy, who can tell me where we made our mistake? Yeah, Hannah. Is what supposed to be negative? What? If we're coming to a stop, are we speeding up or slowing down? And then I would have a negative divided by a negative, which is what? Are you positive? Candy for you, Hannah. Very nice. So 0 minus, answer button, divided by negative 8. And I get a time of, is it 3.82 seconds? Yes? Okay. Nice job. Candy for you. So if you get a weird answer on your calculator, it may be, you may have done a typo, that happens, but first pause, don't panic. One of the first things you want to go check is to see, did I miss a hidden negative somewhere in my assumptions? There's going to be another situation where this shows up, a hidden negative, fairly often as well, in about 3 lessons from now. Time. Oh, I didn't put a box around this one, Mr. Duke. I usually do. Any of you own or been in a Tesla? Nice. I've taken one for a test drive because I'm a physics nerd. They got some pretty good acceleration. So I lifted these numbers from the website. The new Tesla Model X can accelerate from rest. Ooh, I would probably underline the word from rest. To 30 meters per second in 3.2 seconds. What's its acceleration? What's this question asking me to find? I'm going to go A equals question mark. Do you see yesterday, last lesson, when I told you physics word problems are way easier than math word problems in that it's pretty obvious what they're asking you to find, as opposed to in math where you're, what do I let be X? They're contrived, right? Physics, A equals question mark. What else do I know? VI 0. What else do I know? VF30? What's that 3.2? By the way, are we speeding up or slowing down on this question, looking at the numbers? So Hannah, am I expecting a positive acceleration or a negative acceleration? Positive, yeah. And one of the things you'll start to do, or I want you to also get in the habit of doing, is kind of ahead of time asking yourself, specifically for acceleration, am I speeding up? It's going to be positive. Slowing down? It's going to be negative. Okay? T equals 3.2. So the equation I would start with, Naomi, is this one. VF equals VI plus AT, the one that I gave you on your formula sheet. Third line down, equation number 1, first one. I want to get the A by itself. What's going to drop down like a domino? Ka-thunk. Then what? Minus the VI over. That would leave me with, in my mind, I don't write this down, I imagine it, AT. How would I get the A by itself? How would I move the T over? The whole right left-hand side. So that equals A. So it's going to be 30 minus 0 divided by 3.2, which is what? 9.38. Anybody else? Yep. Units, it's an acceleration. Teslas have some pretty good acceleration. They can almost pull probably a little more than a G if you kick it into different modes. Put your pencils down. So, what's your homework? I'm going to skip number 1 because it's kilometers per hour and blah. I'm going to give you number 2, but number 2 you'll have to convert the 45 and the 72 to meters per second first, please. Okay? 3 is I'm going to give you as well, but you'll have to convert the kilometers per hour to meters per second first, please. I think 3, the fact that you're slowing, Hannah, are you going to get a positive acceleration or a negative acceleration if you're slowing down? If I get a negative on my calculator, I won't freak out. I'll relax. Okay? We're going to skip 4. We're going to skip 5. Well, you know, no. Let's do skip 4. 5 is good. 6 is good. 7 is good because it's a roller coaster. Oh, there it is. I knew I'd done California Screaming. 9 is good. You can skip 8. There is no 8, Mr. Dewick. Okay. 10 is good. Skip 11. 12 is good. Skip 13. 14 is good. I'm also going to be starting the next lesson so right now it's 9:57. I'm going to give you about 25 minutes or so, and then we're going to move on. So also if you need to do a mental break or a bathroom break or whatever, now would be the time.